There's lots of information. You got to take the right information. Okay, let's write out our knowns. Let's write out our unknowns. Our knowns. We know that the mass is 50 grams, and we know this because we see the mixture mass is 50. Also, if I do 25 plus 25, that's 50. Remember, 1 milliliter solution is equal to 1 gram. So that's why. All right, I also have the change in temperature. I have delta T is equal to 6.5, and that's a positive number because the number has increased, degrees Celsius. I also have my heat capacity for water, joules per gram per degrees Celsius, and cool. All right, so some things I have to note is I've been given a lot of information up here that I need to figure out how do I transcribe that to then my questions. So my unknown for this case is that delta RH, so that's my enthalpy for that reaction. Cool. Of this neutralization reaction. All right, so let's look at the equations again and figure out which one I need. You guys okay? Can I move it? Yeah. Okay. So with these equations that I've been given, I am thinking about, I want to get to here, because if I get to here, that's the answer to my question, the enthalpy. In order for me to answer that, I need the Q value and I need the N value. All right? Q value I'm going to find out from over here. N value I'm going to find out from up here. So I need to use two separate equations and put them together to get the delta H. Are we okay with that so far? So I will first do the Q value, because I think that's straightforward, and then I'll talk about how do we figure out the N value. So if I was to do that first step of the equation, let me just grab another color. Here's my working. So I know my Q is equal to N times C times change in temperature, which I all have over here. So Q is equal to 50 grams times the heat capacity of water, 4.18 joules per gram per degrees Celsius. And I have times by my temperature change, 6.5 degrees Celsius. So Celsius cancels out with Celsius, grams cancels out with grams. I'm left with joules, which is what I want for this answer. So 50, let me just clear that, 50 times 4.18 times 6.5. I get my Q value equals 1,358.5. Remember that's in joules and my answer needs to be in kilojoules. So I divide it by 1,000. So Q is equal to 1.3585 kilojoules. Are we okay with that? All right, the next one's a bit tricky, so we need to unpack it a little bit because I need to figure out my N value. And they want you to think about, so this neutralization occurs, produces aqueous ammonium chloride and water. So something I have to keep in mind with what they've given me is that they have given me equal amounts of hydrochloric acid and ammonia. Now they do this on purpose because either number that you pick is going to work. If I had different numbers, then I would have to use whatever is going to be the reagent I use up first. So whatever I run out first is going to be the limiting factor, and that's what I would use for this calculation. In this case, they've given you equal amounts of both items, so either one will work when you do your calculations. Does that make sense? All right, so if I want to figure out my moles, I have my volume and I have my concentration, so I need to use then this equation here, which is N equals C times V. So N equals C times V. I know what my concentration is. In this case, C is equal to 1 mole per liter. And I know my volume, because we're using the same volume, is 25 milliliters. We good so far? All right, I got to be mindful that this is in milliliters and that's in liters. So once again, I have to do some conversions. So if I was to convert that, you divide that by 1,000. So 25 divided by 1,000 is going to be 0.25. And now I can start plugging everyone in. N equals 1 times 0.025 liters. Oh, I should write down my units. I see that that cancels out with that. So I get N equals 0.025 moles. We good? Now I just smash everybody together. So delta H is equal to my negative Q divided by my N value. So I have delta H is equal to negative 1.3585 kilojoules divided by 0.025 moles. So now I have, just making sure I got this right though. Oh, sorry, moles, sorry. Not per mole. All right, do that math there. Now we see how it's a negative number. That's good because that tells me it's exothermic, and this reaction here, the temperature rise, tells me it's exothermic as well. So what I should get for my delta H should match what I have enthalpy-wise. Does that make sense to people? It's a nice, again, way to idiot check yourself. All right, so I get delta H is equal to negative 54.34 kilojoules, and then that's kilojoules per mole, which matches what you have for enthalpy. And again, you can round it to 3 significant figures, but it sounds like the questions are willing to accept anywhere between 2 and 4. And that's what that looks like. In most cases, they should be nice to you, and that regardless of which solution you pick, it's going to work. If it looks like you don't have that, then you have to calculate the moles for each one, and whichever is the lower of the 2 moles you use, because that's the limiting reagent that's going to run out first. Does that make sense when I say that? Okay, good. All right, let's look at the marking schedule. Make sure I got my math right, because we all know I do silly things. Next question. We all know this likes to make mistakes. But yeah, I haven't seen this question in a very, very long time, so I wouldn't stress too much. It shouldn't come up, but you never know. There you go. So they rounded 3 significant figures. All right, calculates energy correctly or calculates the number of moles correctly. So what that means is you've done one of these 2 equations. So this is calculate the energy, this is calculate the moles. So one of these 2, because these are both 2 different halves, that is the achieved. So give it a go, work your way through it. Show all your working, don't just write down a final answer. Because the working can mean that you save yourself a merit or an achieved if you make a mistake. This one has correct answer, may have poor rounding, incorrect units, sign, incorrect moles is the only incorrect error. So you've done all the correct stuff, but you did something wrong with your calculation there. Or you just rounded it. So, or you forgot the negative sign. It's a stupid reason to get a merit. All right, correct calculation with signs, units, and appropriate significant figures. So in that case, it looks like they wanted 3 sig figs. I normally do 3 just to be on the safe side, because you never know. But I think that's a relic of the old days. Yeah.
I have a question.
Yep.
You please this moles in this sense way equal, right?
Yeah. So that's both 1 mole, and they're both 25 mils. So if I did 0.025 times 1, both of them had the same mole value of amount.
But if they were different.
Different, take the smaller of the 2, because that's going to be the limiting reagent. That's going to run out first. So that's going to limit, it's going to run out. It's going to limit the reactions. So the reaction's going to stop. But good question. But usually they will give you the same number because they don't want that to be a reason for your error. Because that requires, again, another layer of understanding, which isn't necessarily assessed. Cool.